Consider the function f of x equals 2x plus 1 divided by x minus 3. Here's a graph of this function, and we notice a couple things here. First of all, the limit as x approaches 3 from the left of f of x is negative infinity. So here's 3, and as we approach from the left, we end up going to negative infinity. And the limit as x approaches 3 from the right, you end up going to positive infinity. And so this means that there's a vertical asymptote at x equals 3, and that's what we see right here. And then we also see a horizontal asymptote. And the question we want to look at now is what happens as x gets bigger and bigger and bigger? What happens to f of x? And we notice that as x gets really, really big, f of x seems to be approaching 2. So if we look on the graph here, here's x getting really, 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 really big, and we see that we seem to be approaching the value 2 on the y-axis. So this we have a way of capturing this notion, and we write it as a limit as x approaches infinity of f of x equals 2. So let's make this a little more precise with a provisional definition. There's actually a much more precise definition, but this is something that is workable for now. Let f be a function, and suppose that the value of f of x gets closer and closer to a number L as x increases without bound. Then we say that the limit as x approaches infinity of f of x equals L. And we can also do the same thing for x approaching negative infinity. Let f be a function, and suppose that the value of f of x gets closer and closer to a number L as x decreases without bound. Then we say that the limit as x approaches negative infinity of f of x equals L. So there are several ways in which a limit can approach a value as x goes to infinity. So in particular, let's look at ways in which a limit as x approaches infinity of f of x could equal 1. So one way might be we could approach 1 coming from above. So as x gets really, really big, we see that we're approaching 1 on the y-axis here. Or we could come from below here. We could say as x gets really, really big, we're approaching 1 here on the y-axis, and this time from below. Or we could kind of oscillate around 1, but notice the oscillations are getting smaller and smaller here, so we're kind of centered around 1 on the y-axis. Now remember before we had the limit laws, and the limit laws are displayed here. And I'm going to go through and sort of change them so that they apply to limits at infinity here. So these are the limit laws, and in fact I even have limit laws up here. This is the exact same slide that we had from before of the limit laws. And first thing I'm going to do is I'm going to change this part up here. So before we had the limit as x approaches a of f of x and the limit as x approaches a of g of x both existing. Well, I still want the limits to exist, except now I'm going to have the limit as x approaches infinity. Now we're going to look at law 1. So law 1 says the limit as x approaches a of a constant equals a constant. Well, I can just change that by making it the limit as x approaches infinity of a constant is a constant. Now law 2 is the only law out of all of these that's going to be pretty different from its original form. So originally we had the limit as x approaches a of x to the n equals a to the n. And I'm going to change that now, and this looks a little more complicated. I'm going to come back to this on the next slide, but for now let's just take a look at what it says. The limit as x approaches infinity of x to the n will be positive infinity for any value of n, 1, 2, and 3, and so on. But as we approach negative infinity of x to the n, it depends on whether n is odd or even. If it's odd, then we get negative infinity, and if it's even, we get positive infinity. And I'll look at, like I said, on the next slide, we'll look at this in more detail. Law 3 said that the limit of the sum or difference of functions was the sum or difference of the limits, and that still applies when x goes to infinity. For law 4, it said we could pull a constant outside the limit, and again, that still applies as x goes to infinity. For law 5, we had the limit of f of x times g of x being the limit of f of x times the limit of g of x. And remember, for all these laws, both the limit of both f of x and g of x have to exist, and that still is true here. But if that is true, then yes, it does work as x goes to infinity. For law 6, we had the limit as x approaches a of f of x over g of x was the limit of f of x divided by the limit of g of x, provided that the limit of g of x was not 0. And the exact same thing holds here. And finally, law 7, this was where we had the square root or the nth root of f of x. And again, we have the same exact thing, and we still have the condition that if n is even, that this limit has to be greater than 0. And remember, all of these laws only apply if the limit of f of x and g of x both exist. If one of them or if neither of them exist, then these laws do not hold. And also, analogous laws hold as x goes to negative infinity. So let's look at law 2 a little closer. So law 2 said that the limit as x approached infinity of x to the n was positive infinity when n was 1, 2, 3, or so on. But the limit as x approached negative infinity of x to the n depended on whether n was odd or even. Here's f of x equals x, so this would be the case where n equals 1. And you can see that as x gets bigger and bigger and bigger, it does go off to positive infinity, and as x gets more and more negative here, it goes off to negative infinity. And that's this case where n equals 1, we get negative infinity. Here is x squared, and now you can see what's going on here. As we go, as x gets bigger and bigger positive or bigger and bigger negative, in both cases it goes off to positive infinity, and that's what we have right here for the case 2, or up here for the case 2. Here is x cubed, and again we see the behavior where on one end we go off to positive infinity and the other end we go down to negative infinity. And finally here's x to the 4th, and this looks a lot like x squared where we have both ends going off to positive infinity. One more limit we want to look at is the limit as x approaches infinity of 1 over x, or the limit as x approaches negative infinity of 1 over x. Here's a graph of 1 over x, and from the graph you can see that as x approaches positive infinity, it looks like we are approaching 0, and the same thing with negative infinity, and in fact that is true. And this allows us now to solve limits like this. The limit as x approaches infinity of 4 over x. Using the limit laws, we can rewrite that as the limit as x approaches infinity of 4 times the limit as x approaches infinity of 1 over x, which is 4 times 0, and that's just 0. Later on we'll look at more complicated limits, but for now, just get familiar with the limit laws as they apply to limits at infinity.